Hello guys, today we will discuss LeetCode question number 3203. Find minimum diameter after merging two trees. In this question we are given two trees and we have to merge them such that the resulting diameter of the tree is minimum as possible. Okay. So how can I merge these two trees? We have to choose one point from one tree and the other from the tree 2, and we have to join them through one edge. And the resulting diameter of this new tree should be as minimum as possible. Okay. So before moving ahead, let's first discuss what is a diameter of a tree. Okay. So for to find a diameter, let's first make a tree. Okay. Let's say this is my tree. Okay. Yeah. This is my tree. So the diameter will be this. This is the maximum length between any two nodes, right? This is 1, 2, 3, 4. This is 4. This is the maximum length. Okay. This cannot be the diameter, right? This cannot be a diameter because this is the length which is not the maximum, right? So 4 is the maximum length between any two nodes, so it's the diameter of this node. Cool. Now what does the question say? We have to merge two trees and we have to get the maximum possible diameter. Okay, let's take the first example, tree 1 and tree 2, and we make it. Okay, so tree 1 looks like this. Okay, this is tree 1 and this is tree 2. Okay, now we have to merge it, right? I can merge it. Let's say I choose to merge these 2 points. Okay, so the diameter will be 1, 2 and 3. So the diameter will be 3. Okay, great. Now let's merge these 2 points. Okay, now the diameter is 1, 2, 3, 4. Now the diameter is 4. It's not 3, right? So we have increased the diameter, but we want to minimize it. Okay, cool. Let's choose to merge these 2 points. So now the diameter becomes 1, 2, 3 and 4. Again the diameter is 4, right? So the optimum answer will be to merge these 2 points, because these 2 points give us the minimum possible diameter of the tree. Okay, this is how it goes, right? So for this, how can I find the 2 points which give us the minimum possible diameter if we join them? Okay, this is the question. Okay, to find the answer, we have to first go through this assumption, right? Right. Let's say we have found a diameter, right? Let's say this is one random tree. Okay, this is just randomly made, not thought about anything. It is just random. Okay, very random. Okay, this is one, and this is two. Okay, this is tree number 2, right? And I choose to merge these 2 points. Okay, let's say let's say merging of these 2 points give us the minimum diameter, right? Let's assume that. Now if we choose these 2 points, what does it mean? The total diameter will be diameter of this entire tree, correct? So it will be the maximum distance from this point to the entire tree, maximum distance possible to any node, right? Plus 1, like this edge, plus maximum distance from this node to any other node. Okay, so it will be like, I think it will be this, right? And for this node, the maximum distance possible will be this. Okay, great. So the diameter will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, great. Okay, so what we have to do is we have to find one node from this tree, right, which has the minimum distance, which minimizes the maximum distance from that point to any other point, and we have to do the same for this tree. In short, for this tree, just choose one point which is like the minimum, like the closest from any other point, and also choose one point from here. Okay, for here I think this is the node, right? Because the maximum possible distance is 1 2, right? uh, I can get a distance more than 2 for here, and for here it will be, I think it is 2 also, right? If I choose this point, right, so it will also be 2. Cool. So if I join these 2 points, okay, let me join them nicely. Okay, if I choose to join these 2 points, right, so the resulting diameter will be as minimum as possible, because the distance here is minimized and the distance here is minimized. The length of this edge will be 1, it can't be changed, so the minimum will be 2 plus 2 plus 1, 5. Okay, so I can do this. Now how to find this node, right? This is the real question. So what I can do is, so one thing that I can surely tell, that is, for any node in this tree, the maximum possible diameter will be at most diameter of this entire tree. Like if I take this point, the maximum possible length it can go away is the diameter of this tree, right? Which is like this. So if I go at the mid of this path, right, which will be, I think here, the distance will be the shortest possible. What do you say? Like let's make another a bit more complicated tree. Hmm. Let's make a more complicated tree. Right, this is our tree, right? So the diameter is, I think the diameter is this. Hmm, this is the maximum length, maximum. The diameter looks like this, right? I'm just eyeballing the diameter, right? It's this, right? So a point which is at the mid of this will be the diameter. Okay. The point at the middle of this, right? So which will be 1 2 3 4 5 6 7 8, right? So 1 2 3 4, right? This point will will have the minimum, will have the minimized maximum distance to any other point, right? Which means that the distance from this point to any other point will be the ceiling of diameter by 2, right? It cannot be less than this. 1 2 0, ceiling of diameter by 2. Okay. So which means that we just simply need to find the diameter of the tree, right? And we have to do the ceiling of diameter by 2 for this tree, and diameter of the other tree also, diameter by 2 ceiling of the other tree also, and just add them and do plus 1. We will get the answer, as simple as it gets. Okay, so we have shown here. Now let's try to implement it. Okay, so now how to find the diameter of a tree? Now you might ask it. So it can be done recursively. Okay, let's take this, let's make a new tree again. Let's make a tree like this. It's a bit simple tree to understand better. Okay, this is our tree. Okay, so to find the diameter, what we will do is we will do post order traversal from every node. Okay. Okay, and we will fetch the longest length, longest depth from any node, right? Let's say I am at this node. Okay, I will find the longest depth from this node, from all of its children, from this node, then from this node, and then from this node also, right? For here we will get, from here we will get 1, we will get here 1, from here we will get 1. Okay, and from all these three values we will fetch the maximum 2. Okay, so here the maximum 2 will be 2 comma 1. Okay, now I will add them, and I will and I will do plus 1, which will give me the maximum chain of nodes. Okay, so the maximum chain here has become 4. Okay. Okay, but now we have to return here, from here, maximum length possible from this node, right? So we will return this. So it will be maximum length from all of its children plus 1. So it will be 2 plus 1. Okay, so now the same story goes for this node. It will fetch the longest length from this node, and then from this node it will do the sum, and then after getting the longest chain of nodes, we will just store it in the answer and just do the max, and then return the maximum length. Okay, we will do this again and again recursively till we find the maximum possible length. This. Okay, we will do this for tree 1, we will do this for tree 2, and then do ceiling of distance by 2. Also, one very important observation, right? Here I am finding the longest chain of nodes, right? So for this graph, chain is 1 2 3 4 5 6. Chain is 6 nodes, which means diameter will be 5, right? Because number of edges will be 5, so the diameter will be longest length, so the length will be 5 nodes, which will be n minus 1 nodes. So diameter is equal to 5. Okay, so this is what we are going to do. So let's begin. Implement. First we have to make adjacency list for both tree 1 and tree 2. Let's make it. Also, for a tree, right, which has no cycles, number of nodes will be number of edges plus 1. And for same for edges 2. Okay, I'm just naming it graph because every tree is a graph also. Also, every tree here is bi-directional, right? So we have to connect one point to other, and the other point to current node point also, right? So E0 is connected to E1, and E1 will be connected to E0. Great. Same case for the other graph also. Yep, we have done it. Okay, we have done it. Now we have to find the diameter. For that, let's write a function. Okay. Okay. Chain 1, chain 2. Let's initialize them with 0. Right. Right, this will be our graph, and this will be the recursive function which will do post order traversal to find the diameter. Okay, great. We can also pass diameter here. I think it's good, right? We can pass it by reference, then we will not need this. Yep, I think this is good. Okay. What will child graph node equals to parent. If node is not equal to parent, also as I said, now I need to fetch two maximum lengths from all of its children, right? We have to fetch two maximum lengths. Okay, so for that, what will I do? Okay, let's say I have gotten like these lengths. Okay, 2 4 1 3 1 1. Okay, so I have to find two maximum lengths from this, so that will be 4 and 3. Okay, so now how can I do this? Okay, so what can I do is I can maintain a vector which will have at most size 2. Okay, uh, let's say I am iterating from here to here. Okay, so first I will store 2. Okay, great. Then I will store 4. Okay, very nice. Now I will sort at each moment. I will sort it in decreasing order. So okay, so now 4 2 becomes 2 4. Okay, now I have gotten 1. Okay, I will do 1 again. I will sort. Now it will become 4 2 1. Sorry, here it will be 4 2, right? Yep. Now after sorting, it will become 4 to 1. Now as you can observe, the size has become more than 2. So what I will do is I will just remove the last element, which will be the shortest one by guarantee, because we are sorting it in decreasing order, right? So at each step we are getting the maximum two values. Now let's see, I push 3. Okay, so it will become 4 to 3. Again I will sort, it will become 4 3 2. Now the size has become more than 2. I will just pop the last element again. As you can see, we got the maximum 2. Now I will add 1. 4 3 1. Again I will sort, it will be remaining the same. Okay, now the size is more than 2. Pop the last element, same for 1, right? So we get the maximum 2 elements through this algorithm. Let's do that. Right, this will be at most. Size will be less than or equal to 2. Okay, great. Solve length. Right, now I am making a recursive call to this child, which will have the parent as current node, and we have to also pass this graph child node and the diameter. Great. Okay, I have done it. Now I will push it into the max length vector. and sort it in reverse, right? If the size, if max, mm, if the size is more than 2, I will remove the last element. Great. Okay, we have done this. Also, there is one edge case. Let's say we have one tree and it only has one child. Okay, like I have this tree and I am at I am here. Okay, so this only has one child. So I cannot make any new bigger diameter. Okay, so what will I do is I I will just compare the answer. I'll just compare the maximum chain with the length of this, if it makes sense, right? Or maybe just do this. So what will I do is just take the sum of the maximum all. I will simply take the sum of all the elements in the vector and just add one. The one will be this parent, this current node, right? It will handle the edge case. Now new chain, right? This is not diameter, this is chain. Let's do chain, right? Now chain will be maximum of chain and accumulate max. We will take the sum of all the elements in the vector max length. Okay, great. I can do, no, I don't need long because the constraints are okay, right? So we don't need that. And I also don't need this long conversion. And and I will just simply return the first element of max length. Also, one more edge case that we need to discuss will be if I encounter a leaf node, right? Let's say this is a tree and I encounter a leaf node. In that case, this sum will be 0 and I'll just simply do +1. Okay, great. If we have any element in max length, I will just do +1, or I will do simply 1. Yep, we are done with this. Okay. Now I will just do len of, oh, also we have to do a +1 here, right? Because lengths of all the two maximum elements plus the current, right? So it will be a +1 here. Okay, great. Now len of graph 1, let's say current node is 0 and parent is -1, because node 0, we will assume it has no parent. It will be -1 and the chain will be chain 1. We want to store the diameter for tree 1 into chain 1. Same for graph 2. Okay, now we have gotten the diameter for both. Okay, now we have to simply return chain. First we have to make the diameter, we have to convert chain into diameter, right? So chain 1 minus equal to 1, and for same we'll do -1 for from both. Now we have to find the ceiling, we need to find the ceiling of chain of this diameter by 2, right? So 1 plus 1 by 2 plus chain 2 by 2 plus 1. This will be our algorithm. Let's first do some dry running, and we'll see. Okay, where edges 1 dot size plus 1, correct. Chain 1 0 0, okay. Graph 1 graph 2 n comma m, okay. Edges 1, graph 2 for e1 for 0, length graph 1 chain 1 length chain 2, okay. Now let's go here. Max length, okay. Child graph node, if node is not equal, oh, if child is not equal to parent, right? We don't want the child to be parent, because if I'm traversing for this node, right, I will go to this and this, so I don't want to go to this, so this is parent. That's why child is not equal to parent. I i, I have put this condition here. Length currently will be length of graph child node and chain, okay. Okay. Sort dot pop back, great. Okay, correct, looks correct. Written max length, अगर मान लो max, what is the max length of size? If there is any child, it will just return the maximum length and then plus one, or else just the current node. Okay, looks correct to me. We will find length first and then find length for second, and convert them into the diameters and do diameter upon to seal for both them plus one. Let's run it. Yep, both of them got accepted. Let's try to submit them. I hope it's not a wrong answer, but let's try. Okay, it got a wrong answer. Let's see what we have missed. I hope it's some petty issue, but we will see what it is really. Hmm. I am sure it's some little issue, but we will fix it out. Hmm. It will add to, okay. Length current equals to length of graph, okay. E0 E1 E1 E0, this is correct. Okay. Okay. Hmm. This looks correct to me. 0 plus 1 and maximum size is maximum 0 plus 1, okay. Graph 1 n or m, edges 2 0 1. uh, okay. There must be some edge case that I am missing. Let's see if we can find it really quickly. E0, E1, E1, E0. Okay. Length looks correct. Parent has been declared correctly. Okay, I am converting the chain into that diameter. That's also correct. Maybe I need to. No, it's giving 6, but the output is 7. Okay, 0 1 0 2 0 3 0 1 0 2. Okay, so it will be connected to 0. Great. um, Maybe we should make this graph here only. Let's make it really quickly. Okay, 0 1 0 2 2 3 and 3 6 8 7 4 8 3 connected to 5, 3 is connected to 9. Okay, 9 and 8 is connected to 7, and okay, 4 is 8. Okay, 5 connected to 4, 4 is connected to 8, which is connected to 7. Okay, 8 1 2 3 4 5 6 7 8 9. 1 2 3 4 5 6 7 8 9. Great. And the other tree that we have is 0 1 0 2 0 3. Cool. 1 2 3 4 5 6 7. 1 2 3. Right. So here we'll get 1 minimum number. Okay, 1 2 3 4 5 6 7. Right. So for 7 we will get 4. 4. Why is it 7? I cannot. I don't know. Why is it 7? Like 1 2 1 2 3 4. Right. So if I connect 5 and 0, what will I get? 0 1 0 2 0 3. Okay. Okay, 1 2 3 4 6. 1 2 3 4 5. Why is 7 expected here? I don't know, man. I really don't know why is 7 expected. 0 1 0 2 3 2 3 6 8 7 4 8 5 4 3 5 3 9. It's okay. 0 1 0 2 0 3 0 1 0 2 0 3. But how come minimum diameter is 7 if I am able to find diameter to be. Oh, got it. One really crucial thing that we have forgotten is, even if the diameter for the resulting tree is this, the diameter for the individual trees can be more than this value also. So what we have to do is maximum of chain 1, chain 2, and this, and it will work because I will explain. As you can see, if I make this tree, okay, let's say I have made this tree, okay, as given in the example, as I have made this, okay, what can happen is the diameter of this resulting tree passing through this is like this, okay, but this is not the maximum. The maximum, it's entirely possible that the maximum diameter, that the diameter can be contained inside the separate tree also, right? It can be this or it can be this one. So we will just do the maximum here for the separate diameters. Now it will get accepted and it will get submitted also. Let's see. It should be accepted. Yep, it got accepted. Although runtime it's a bit slow, I don't know why, but yeah, it is what it is. So let's discuss time complexity here. It seems like time complexity here is, this is linear, this is linear, this is simple post order traversal. It's nothing complicated. This function is constant time because the length of maximum len is at least at most 2, so it's considered as big of 1, right? all of this is all of this is linear, so constant time. This entire thing is post order traversal, which is covering every node exactly 1, so it gives me big O of n time, right? So this is big O of n, this is big O of n. Overall time complexity is big O of n, linear. Also the space complexity is linear. Let's see. Oh, I don't have any premium subscription anyways. So this was the approach, this was my approach, and I also tackled one problem here and how I got through it. I, I also showed that. So I hope you like this approach. Like and comment whatever you feel about this, and let me know if you need, and if you need any assistance or any help. Thank you.